right. So I'm Jared Forsyth. If you want to follow along, type safereact.surge.sh, and I'm Jared Forsyth on Twitter. I do mobile and web development at Khan Academy, where we're working to build a free world-class education for anyone, anywhere. And we're also hiring, so if that sounds interesting to you, come talk to me. I'm also one of the co-hosts of the Reasontown podcast. So if this catches your interest and you want to learn more about Reason, go check that out. My goals for today is for each of you to be able to answer these three questions. Why Reason? Why is it interesting? And especially in the context of React. And what does it look like to use a little bit of Reason? And then how do I get started? How do I start to sprinkle a little bit of Reason into my current JavaScript React code base? But before I get started, I have to ask a question. Who here likes types? Okay, a good number of people. For all of you who didn't raise your hands, I gave a talk last year at ReactConf that will hopefully change your mind. But I don't have time to do a deep dive into that right now. So why Reason? And actually, probably many of you are thinking, what is Reason? So I'll do that too. Reason is a new syntax and toolchain for OCaml. And OCaml, if you haven't used it, you may have heard of it in those blog posts that are like 5 languages that will change the way you think about programming. It's been around for 20 years, but the community has stayed pretty small. There's been a lot of work in academia, lots of master's theses and dissertations written about it, but there hasn't been as much of a focus on growing a community, being easy to get started with, that kind of thing. So the goal of Reason is to do for OCaml what Elixir did for Erlang. That is, put a new syntax on top of it that looks a lot more like mainstream languages, making it easier for people to come from JavaScript or Java or what have you. And also focus a lot on building documentation, building a community, and making it as easy as possible to integrate with current JavaScript code bases. And probably the biggest reason that I'm going to try and sell you right now is that Reason is the best way to write React. This is a bold claim, especially because React is a JavaScript library. I think, how is it possible that a different language entirely doing bindings over the bridge would be better than writing React in the host language? And it turns out that React is not really a JavaScript native framework, at least fundamentally. Because when Jordan Walk was originally prototyping React, he did it in standard ML, which is a sibling language to OCaml. And that's why some of the core ideas and paradigms in React almost feel foreign in JavaScript. For example, immutability is core to the way we think about state in React, right? You're not supposed to mutate objects very much. You're not supposed to mutate state. If you do, weird things will happen. And so we have convention in React code bases. If you see somebody mutating stuff in a code review, you say, hey, that's not how you do it. You spread, and you kind of jump through these hoops to maintain immutability. In Reason React, that's what you get out of the box, right? It is built into the language from the ground up. And the same thing with types. When React was first released, it had these prop types to try and give you a little bit more security about the contract between a component and its client. But it's a halfway measure. It's trying to get towards types, but it wasn't a full thing. In Reason React, we have them baked in, and they're checked at compile time. So you might now be thinking, well, types, I've got that. I've got Flow or TypeScript. So why Reason and not Flow or TypeScript? And this is an especially natural question because Facebook is behind Flow and Reason, which seem like they might be competitors. So what's going on there? And I drew you some pictures to try and illustrate this a little bit. Here we have the USS JavaScript and the USS OCaml. And you look at the USS JavaScript, it is a party, right? There's like fireworks, there's a pie in the window if you can see it. There's like one of those figurehead things. I don't actually know what that's trying to be. There's a pool table in the middle, deck chairs. And then you go over to the USS OCaml and it's like, there's nothing even going on here, right? It's gray, it's drab. But we're actually not seeing the most important part of the boat. And that's the hull. And clearly, JavaScript has more things going on. there are some holes in the boat. It's not as sound. It's going to let some stuff in. Now, this doesn't mean that your boat is going to sink, right? We have ways to deal with water when it comes on. You just add a pump that pumps the water back out again. And actually, there are probably too many holes for just one pump. Let's add some more pumps. Although at this point, now you can't even play ping pong because the pumps are in the way. And it'll slow down your boat. Anyway, so that's where TypeScript and Flow come in. It's like, let's patch up some of these holes, right? And then on the OCaml side, Reason is adding a little bit more party to the USS OCaml. And so it's really a difference in direction. Right? Flow and TypeScript are starting with JavaScript, which has a lot of party, but is quite a leaky boat, and trying to patch some of those things up. And then Reason is taking OCaml, which has a very sound basis, and just adding a lot more niceties on top of it. To explain this in a little bit more of a dry way, here's a little chart for you, where JavaScript is really easy to use, but very low on the safety side. And then OCaml is much more safe, but not nearly as easy to use. And it's so much easier to start with something that is a complete package as a language and add on niceties, because you don't have to compromise on safety at all. Whereas starting with JavaScript, in order to get some of the safety, it actually gets harder to use. So here's some of the key differences. And I want to point out stability, where in Flow or TypeScript, we use Flow in our JavaScript at work. And we've, every month or so, they release a new version that, the type inference is a little bit better, the rules are better, it works better with JavaScript, but there are breaking changes. There are errors that weren't there before, because it's catching new things. Or there are things that used to be errors that aren't anymore. And so we're like 6 months behind on Flow releases because we tried to just do the NPM upgrade, and suddenly there were thousands of new errors, and it's like, we can't handle this right now. So the maintenance burden of using a type system that's evolving quickly and trying to be more aligned with JavaScript is quite large. Whereas with Reason, we're building on top of OCaml, 20-year-old language. All of the kinks have been ironed out. It's not going to change fundamentally in a hurry. And so there's a lot more stability there. Of course, Reason's downside right now is that the community is very small. We're just starting out. If you look at Stack Overflow statistics, Reason and OCaml, if you take those two tags together, you have about 5,000 answers. TypeScript has 50,000. So that might be a reason to say, I'm not ready for Reason if you've got a large team. For example, at Khan Academy, we haven't adopted it yet, but I really like the benefits, and I hope that I'll be able to integrate it here in the next year or two. So kind of the TLDR on that. If you're not ready for a whole new language, but you do want some types, try out Flow or TypeScript. It's definitely better than just using JavaScript on its own. A lot of people ask me about Elm too, and I'm actually going to skip over this for the sake of time. But if you're interested, the TLDR on that is they're both great. I love Elm. We actually borrow a lot of things from Elm. They set a great example for us. And you can talk to me later if you want more info on that. So what does it look like? Right? Hopefully you're interested now. Reason seems like something that you could get behind. Here is a little bit of basic syntax. And we put a lot of effort into making it as accessible to people coming from JavaScript as possible. So here we've got an arrow function. And everything should look the same, except there's no return statement. In Reason, just about everything is an expression. And so the function, just the result of the function is the result of the last expression inside of it. And this gets really cool when we come over here to this switch block, which is an expression. So you can say let animals equals the result of this switch block or the result of this if block. Another neat power tool that Reason has are named arguments. And these can be provided in any order. And you can provide default values, or you can say this is an optional argument. And this actually melds really, really well with React. So when we transform the JSX into a React call, it's just the optional named arguments. And so they can be in any order. And speaking of JSX, of course, we have it in Reason because we want React to be kind of a first-class citizen. And a lot of this should look the same as well. Here is passing an event handler to our onClick that just logs to the console. This is what it looks like to use a custom component. It's exactly the same. Here we get to take advantage of the fact that an if block is an expression. You can just dump it in. You don't have to get lost in ternaries. How many people have got lost in ternaries when you're doing, yeah, JSX? So when I'm writing JavaScript at work, I really want Reason because there are just all these goodies that you get in a functional language where React really feels at home. Another fun bit here is prop punning. Now in JavaScript, if you provide a prop without a value, it just is that prop equals true. But what comes a lot more in handy is in Reason, so data without a prop here is data equals data. So it just passes in whatever variable is that name. And that really cuts down, especially when you're passing a lot of props around. So let's dig into some React patterns. What does it look like to make React components in Reason React? And here's a basic one. This looks a lot different than the JavaScript. But basically what's happening, we're creating a component prototype, essentially. And this is a stateless one, so we're not going to be having any state. And then we extend that component using object spread and say, here's the render that we're going to provide. And then in the render, we can use one of these props. Like I said, this is a named argument to the make function. And that's where all the props are. And we'll just use one of those props in the render. So when we get to local state, this is where Reason React really shines. This is where the designers of Reason React look at React paradigms, what's working well, how can we bake that in? How can we have that from the get-go? And so this stateful component looks like we've got a little bit of Redux in there because we declare an action type up at the top. This is a counter. It can either go up or you can reset it to a number. And then we have a reducer where it takes an action and the current state, and it'll do a switch on that action and figure out what the new state should be. And then here in the render function, self.send is the same as dispatch from Redux. So we just send a new action. And here's an example of sending an action that contains a value. So resetting to whatever number we get from this callback. And this is really nice because you get all of the, or a lot of the benefits of Redux, where you had the organization and the clarity of Redux, but you get the portability and composability of local state. One of the biggest benefits of React, in my opinion, one of the things that drew me to it was the idea of you have these components, and there are a lot of conventions in place that makes them reusable and composable. Right? You distinguish between props and state, and you don't mutate things. So if you have a component and it's designed well, you can just pretty much put it anywhere. Once you bring in Redux, it breaks that completely. I was trying to refactor part of our React Native app the other week, and there's a lot of Redux in there. And I wanted to be able to take a couple of the connected components and use them in a different Redux context. With a different Redux global state. And I eventually gave up. I had to refactor in a different way because a connected component is completely tied to the general shape of that global Redux state. With this, you have kind of declaring actions and seeing all the state in the same place, but it's still local to a component. And so you can refactor it independently. You can move it around. Another example is and this takes advantage of React and the powerful type system is making illegal states impossible. In my talk last year, I talked about this in the context of Flow, but it just works so much more smoothly in Reason. Here's an example in JavaScript of a kind of component that I'm sure lots of people have made, where you need to fetch some data. And You don't get it immediately, so you need to have a loading state and then an error state if it doesn't work. And if it does work, then you display the data. So here we have our state declaration where data and error are both initially null. And you fetch something and set the data, set the error. And in render, you have a couple of if statements. If there's an error, show it. If there's no data, don't then show loading. And then if we have a data and there's no error, then show the main view. And this works, but it bugs me a little bit because the shape of the state is a little ambiguous. What would it mean for both data to be there and for there to be an error? Now, of course, I didn't write that into this code. I never set state and data, or I don't never state data and error at the same time, and the nature of promises is only one of those will be filled, but it's implicit. And as components get bigger, as more people work on them, it's a lot easier for somebody to put the state into a case that you didn't think of. But it's totally allowed by the way that you set things up. If we go over to Reason, you create the state type such that there are only 3 possibilities. Either it's loading, or it failed, or it loaded. There's no loaded and failed somehow state. And then you fetch something, looks fairly the same, and in the render, you take care of each of those cases. If it's loading, we go there. If it failed, we go there. If it loaded, we go there. And the compiler actually helps you with this step, because if you fail to account for one of the possible states, it'll yell at you. So you have the type checker making it so you can't put it into a weird state, and it makes sure that you handle all of the possible states that you defined. So how do you get started using Reason in your React app? And this is one of the things that we put a lot of effort into, making it so that you have your JavaScript, your React, your bundler doing whatever. And it's actually not very difficult to just make one component in Reason or put a little bit of business logic into Reason. So to get the compiler, it's actually just an npm package, BS platform, which stands for buckle script. And you need to give it a little bit of configuration, tell it where the sources are, that you're going to use common JS style modules. And then when you run buckle script, it will take each of your .re files and turn them into a .js. And then it's really easy, because from your other JavaScript, you can just require that created JavaScript file. Here's a little example. We have some component that we defined. It's a React component. And then Reason React gives us this wrap reason for JavaScript function that will do everything that's necessary so that we can expose this as a JavaScript-ready React component. And what we need to provide is a way to get from kind of JavaScript's untyped bag of props and then call our make function. So we have our JavaScript props, and then we get out the name, we get out the age, and we call that function. And then Reason React does whatever magic it needs to. And then from JavaScript, it couldn't be easier. JavaScript doesn't need to know at all that this component came from Reason. We can also go the other direction. So say you have some component that is called some component, and it's written in JavaScript. You do this external declaration, which bucklescript will turn into a require. And then you have wrap.js for Reason, and it's the same thing but the other direction. Right? You get Reason props as these arguments to your make function, and you pass them in as a JavaScript object that Reason will then bundle up and instantiate a normal React component with. So that's all you need to get started. You can write a React component in JavaScript, use it from Reason, and the other way around without a ton of hassle. So what's next? I want to give you a little bit of teaser. I'm excited about a lot of things that are happening in the Reason community. One of the biggest things is the possibility to compile Reason not just to JavaScript, but to native. Because it's OCaml under the hood, and the OCaml folks have done amazing things with cross-compilation, where you can compile to native desktop, but also native iOS, native Android. And I was really interested in this, so I did a little bit of legwork, and a couple of months ago, I shipped an app to the App Store and the Play Store, written in native Reason, rendering to OpenGL, and it also runs on the web. Also coming up, we've got, you can clap if you want. Also coming up, we have ReasonConf in May. It's going to be in Austria. I'll be speaking there and a bunch of other people. And that's just about all I've got. If you want to learn Reason React and really dig into this, I wrote a big, long explainer tutorial with a bunch of examples and interactive things you can check out. Also, the Reason Town podcast, and I've written a bunch of blog posts about Reason on my website. Thank you very much.